whatever part you're seeing is a basic BIW part. I can tell you how to design in steps. I can explain you this.
Okay, sir.
Can you tell me the difference between order geometry and geometrical set?
Right, sure. I'll tell you that. Basically, the difference between ordered geometrical set and geometrical set is that when you design parts in ordered geometrical set, the editing of the model will be easy. Okay. In case of geometrical set, that editing will not be that much easier. Okay, what I mean to say is that basically the in ordered geometrical set and geometrical set, whatever you can add is the same. Surfaces you can add, the wireframes you can add.
May I add some points, sir?
Yes, yes.
Uh, Sir, maybe in order geometrical set, suppose we have created some surfaces,
Huh.
and then we have make a join of these surfaces.
Huh.
Then in order geometrical set, the join is the final product of the surface. But in only geometrical set, then we get the two separate entities like a join and the surfaces in our geometrical set. But in order geometrical set, the join is the our final product.
Okay, but okay, understood. But in a simpler way, if you say in ordered geometrical set, so I'll show you. So I have done the modeling in ordered geometrical set. So what I have done, when I right click here and when I do define in work object, I can see, I can go step by step. So first I have done the sketch, then I have done extrude. Okay, so like this I can go in ordered geometrical set. But in case of a geometrical set, okay, so since it is having some references inside, it is not able to paste. What I'll do, I'll sketch here itself. Basic sketch should be constrained. All those basics should be taken care. Okay, it should be in green color. Okay, proper dimensioning of sketch should be done. Okay, okay. So just I'm showing. So now I'm not doing. So in case of ordered geometrical set, I
Okay.
will not be able to do a define in work object inside the geometrical set. So even if I right click on this sketch and do a define in work object, it will go to the geometrical set itself. Okay, this underline means that you are currently working here. Okay, but in case of ordered geometrical set, when I go to sketch one and when I do define in work object, only that sketch comes. So the editing will be easier in case if you do it in a ordered geometrical set. You will know the process flow, how the design has happened. So that process flow you will know in case of ordered geometrical set.
Okay, OEMs are using order geometrical set or a geometrical set?
When I was working, I was using ordered geometrical set, but the same company was using geometrical set earlier. That depends on persons as well. So there is no such rule when I was working, you should use this. This was not there. But your editing will be easier in case of a ordered geometrical set. I was using ordered geometrical set only.
Okay, for an example, somebody working in a plastics A to B surface conversion. They are maintaining the futures in A class, B class, C class like that. Okay, for every futures they are using separate one geometrical set. They are creating under the order geometry or fully they are maintaining geometrical set A, geometrical set B like that they are creating.
Okay, I'm not sure about plastics, but in case of BIW or a sheet metal part, what you can do for features, if it is a big part like a body side outer panel, you can create a ordered geometrical set named features. Then inside that, there will be multiple features for a bigger panel. Okay, so inside that, you can again rename the features or you can add again ordered geometrical set and like embossers, maybe depressions, maybe bird beak, strengthening ribs. So you can add features like that. Understood or not?
Yeah, yeah,
I'll just show
understood.
you. I am adding ribs. What I'll do, I will add all my strengthening ribs. I will design all the strengthening ribs here. Okay, that is based on persons as well, how much they need to add, how the specification tree you want to be. That depends on person as well. Because if you see here, I have designed this part in an ordered geometrical set only. The complete part I have designed this in ordered geometrical set. But it should not have been the way. As Nishita asked, she has asked how the design should happen. Okay, basically the design should have been like I should have created a ordered geometrical set for my input surfaces. So I have some input surfaces. The next ordered geometrical should
So
have been basic
what is your
surfaces.
input surface? What are your input
Yeah.
surfaces?
In no. See, in this case, there are no any input surfaces because I have designed this part as just a part only. Okay. In real world cases, my input surfaces would have been this surface, this surface. Okay, the panel is getting welded onto. Assume that. Okay, just a minute. Suppose I am given with a panel. Consider this as a floor panel, front floor panel or something. Consider this as a panel, and I have been told to create a cross member or long member onto this panel. Okay, so I have my floor panel.
Okay.
So in input, what I will do, I will create an extract of the panel. Okay, assume that I have the floor panel and I have created an extract of that. So that extract will go as my input. Understood or what?
Okay.
Then what I will do, I will be, my aim is that I need to create a cross member or a bracket which is getting welded onto this panel. So for that, then I will, based on this surface, I will generate the sketch. Then the welding flanges will be this one.
Sir, but how you decided the dimension of this
Okay.
square-like box? Huh?
Dimension of this. So for this box, the dimension, because I don't have any constraints here. So as such, I have designed the bracket or the cross member. In real case, what you will be having, you will be having some interfaces coming here. Okay. Else the dimension can be checked using benchmarking. The similar cross member is there in the other vehicle, your benchmarked vehicle. Else the other way is that you will have to see why this is used for what purpose this bracket is used for. What is the mounting coming on this particular bracket we are using. Basically, all inputs what I have told you earlier that has to be considered. In real world, your this sketch, your constraints will be interfaces. Probably if it is in the underside, you will have your propeller shaft going. So you will have to maintain some minimum distance, or you will have some other lines going. So based on that, you will have to dimension the cross member.
Okay.
Okay. Other than that, the initial step is that the interfaces drive your part. Okay. Other than that, whatever target setting points I have told you, those has to be considered. Okay. The part should be strengthened or rigid enough to withstand the loads.
Okay.
Okay. So ideally, I have an input surface here.
Okay.
What I should have done, I should have extracted these two surfaces. Okay. Then I should have trimmed this. So what I'll do, I'll show you. So I now I have created this sketch. Now I need the two flanges of this bracket. So what I'll do, I'll create an extract now. So I have created an extract. Okay. So my input surface as such I will keep. Okay. I will not work on my input surface. Now I have an extract of this input surface. Now what I'll do, I need a welding flange over here. So for that, what I'll do, I'll just extend this. Okay, so it's getting extended. Now what I will do, I will trim it. Okay, so now I have got my welding flanges as well. Okay, you understood how I have used my input surface to generate my bracket.
Yes, sir.
Okay, so this is how the design process happens. So what I have shown you is for some underbody parts. For upper body parts, apart from the exterior parts like door panel, hood panel and all, those will be derived from styling surfaces. So what I have shown you, these are not from styling surfaces. Okay, I have shown you, you have the floor panel and you need to design a cross member or a bracketry onto that. Okay, so this is how I will use my input surface. Okay, so now with the input surface, I have the welding flange. Okay, so the basic surfaces has to be created in a geometrical set named surfaces. Okay, then the operations you do like trimming, splitting, those can be in another geometrical set. Then the fillets you are adding, those can be in another geometrical set. Then the features you are adding, those can be in another geometrical set. That depends on how you design. When you add more and more geometrical set, if you're comfortable with that and if you find that easy, you can do like that. As a minimum, at least you should create some four geometrical sets. For one for input, one for creating the surfaces, one for operations. Maybe in operations itself, you can add the features as well. That depends on you. I'll show you. Okay, so in this case, what I have done, since I was not having any input surfaces and all, basically my intention was to teach students how to use the different tools or how the design process will be. Okay, so in this case, what I have done, I have created a sketch, then a extrude has been done, then trimming has been done. Okay, then I have done the edge fillet. Okay, this area I have done the edge fillet. Then for this, I have created this for creating, this is known as a ribs or a bird beak, you can tell. Okay, then I have translated those because I needed multiple bird beaks. So my intention was to teach them all the tools. Then trimming has been done. I wanted to create a stepped surface here. So what I have done, I
Sir,
have offsetted this.
Sir Rishikesh here.
Yes, Rishikesh.
Instead of translating, can we use power copy?
Power copy can also be used. Power copy can be used, no problem. Again, I am creating a stepped surface. Okay, so I have created the step surface and I am making a step here. Okay, so now I have done a sweep. So this is how an emboss will happen here. Trimming of that surface has been done. Then I have done edge filleting into that. I wanted this in both sides. So symmetry has been done. Trimming. Okay. Then based on my size of my part, I have splitted the part. Okay, I need this much only. Then edge filleting. Okay, finally edge fillet onto everything. Then this one I have created using a sweep. Finally some hole additions and all.
Sir, what is the
Yes, sir.
like the middle that sweep we have used for what purpose? Like what is this? This one, yes.
This
Like
Yeah, this one basically we will add two parts for strengthening the part. Okay, this kind of features based on experience you can add. Else, when you receive your result from the CA team, you will be adding this kind of strengthening ribs or stiffener beads. Okay, so this will help the part to be more rigid. Okay, part will get more strength when you add features like this.
do you change the shape of this considering the stress concentration because of the hole at the center?
See, I don't have any result of this part. Okay, I don't know what is the stresses coming over here. I have not considered any stress concentration over here. Okay, so as a basic rule, you don't know what this part is being used for. Okay, so as a basic rule in sheet metal design guideline, there should be some 2T difference between the hole to the edge.
Yes.
Okay, so that only you need to capture here. Okay, based on the thickness of the part, you need to keep some minimum 2T or 4T. Suppose it is 1.5 mm thick, and you should keep some 6 mm gap between the edge and the hole. Okay, so those guidelines you have to adhere first. Then when you are checking in analysis, if it is failing, you need to remodel it or you need to reshape the rib value.
Avinash, we know
Yes,
what are
Vinod,
the
yeah.
analysis they will be doing on the model in real case?
Right. Yeah. In real case, they will be doing the CI durability. They will be doing. So how durable your part is. Okay. Basically, it is, you can tell it as the strength checking of the part, whether your part is meeting the requirement. Okay. Consider I am having two mountings here. So what they will do in CAE, the weight of the mounting they will consider. They will give the boundary condition. Okay. The weight of the part will be added here.